Next data repository is data warehouses. Consider a successful international company or electronics, which has branches around the world. All electronics has branches in Chicago, New York, Toronto, Vancouver, etc. So, a company has multiple branches and each branch has its own databases. Data source in Chicago, data source in New York, data source in Toronto, data source in Vancouver, etc. Now, the president of all electronics asked to provide an analysis of company's sales per item type per branch for third quarter. That is, provide an analysis of company's sales per item per branch for third quarter. This is a difficult task because the data is present in different locations and in different databases. Since the relevant data are spread out over several databases physically located at numerous sites. So, if a company has different branches and each branch has its own data source, then the performing the analysis is a difficult task because the relevant data are spread out over several databases physically located at numerous sites. So, the issue is solved using data warehouse. That is, the data warehouse makes this task easy. So, a data warehouse is a repository of information collected from multiple sources stored under a unified schema and usually resides at a single site. A data warehouse is a repository of information collected from multiple sources stored under unified schema and usually resides in a single site. The data warehouses are constructed using the process of data cleaning, data integration, data transformation, data loading, and periodic data refreshing. The data warehouse is constructed via the process of data cleaning, data integration, data transformation, data loading, and periodic refreshing. So, a typical framework of a data warehouse is shown in the figure. This is a typical frame of data warehouse. Different data sources. Data source 1, data source 2, data source 3, etc. Data source n. Now, in each database, data source perform cleaning operation. After cleaning, data cleaning, integrate the data sources into a single source. Now, entire data are stored in the different form using transformation. By using transformation, all the data are in a common format. Next, load and refresh. Loading. Data loading means the data to the data warehouses are not updated frequently. It is the data is loaded into the data warehouse in a periodic manner. So data is loaded in periodic manner, and refreshing is also performed. Loading and refreshing. So the main operations that are used to construct a data warehouse are cleaning, integration, transformation, loading, and so the data is available in the database. When the client want to analyze the data in the data warehouse, a query is given and that query is executed. The result of query is analyzed using different tools. So query and analysis tools are available here, which are used to execute the query and retrieve the result and perform analysis on the result. So data warehouse. What is data warehouse? Data warehouse is a repository of information collected from multiple sources, stored under a unified schema, and usually resides at a single site. Data warehouses are constructed via the process of data cleaning, data integration, data transformation, data loading, and periodic data refresh. A typical framework for the construction of a data warehouse is shown in this figure. Now, the data warehouse mainly focuses on decision making. So, to facilitate decision making, the data in a data warehouse are organized around subjects. The data warehouse organizes the data around major subjects. Example, customer, item, supplier, and activity. That is to facilitate decision making. The data in the data warehouse are organized around major subjects like customer, item, supplier, and activity. Now, the data are stored to provide information from a historical perspective. That is, data warehouse provides historical data. historical, such as from the past 5 to 10 years. Historical data of the past 5 to 10 years. The data available in the data warehouse are summarized data. Data warehouse provides summarized data. This summarized data is available in different level of abstraction. Example, rather than storing the details of each sales transaction, data warehouse may store a summary of transactions per item type for each store. Instead of storing the details of each sales transaction, data warehouse stores the summary of transactions per item type for each store. Or data warehouse summarizes to a higher level for each sales region. That is, branch-wise data is converted into some region-wise. Okay, then to the total company. So the three points to note are to facilitate decision making, data warehouse organizes data around major subjects like customer item. Data warehouse provides historical data of about 5 to 10 years, and data warehouse gives summarized data. This summarized data is represented in different levels of abstraction. Now, how data warehouse is modeled? Data warehouse is usually modeled by multi-dimensional database structure. Multi-dimensional database structure is used to model data warehouse. Here, each dimension corresponds to an attribute or a set of attributes in the schema. And each cell in the multidimensional database stores value of some aggregate measure like count or sales amount. The actual physical structure of a data warehouse may be a relational data store or a multi-dimensional data. A data cube provides multi-dimensional view of data, and it allows pre-computation and fast accessing of summarized data. So the data warehouse is modeled by multi-dimensional data structure, multi-dimensional database structure. In multi-dimensional database structure, there are different dimensions. Each dimension corresponds to a particular attribute or a set of attributes in the schema. Each dimension corresponds to an attribute or a set of attributes in the schema. And each cell stores the value of some aggregate measure. Each cell stores some aggregate measure such as count, sales amount, etc. The physical structure of data warehouse may be either a relational data store or a multidimensional data. So the physical structure of a data warehouse may be either a relational data store or a multi-dimensional data. Now, a data cube provides multi-dimensional view of that. Data cube provides multi-dimensional view of that. And also it allows pre-computation and fast accessing of summarized data. So multi-dimensional database structure is used by data warehouse. Here the points to note are dimension, cell, then multi-dimensional data. Now, this figure shows a multi-dimensional data. This is a three-dimensional data, 3D data. The x-axis or x-axis represents item in types. Y-axis represents time quarters, and the third axis represents addressing. Each data cube is a result of some aggregate measure. Here the sales amount in thousand. This cube is a 3D point. The three dimensions of this point are address value Vancouver, time value Q1, item type security. So this is the total sales for the item type security in the first quarter in Vancouver. That is this value. Now consider this. This cube represents the point Vancouver Q1 home entertainment. Now what is about this data cube? Here is a data cube. Toronto first quarter home entertainment. Okay. Now we can perform some operations on the given multidimensional data. Two operations are shown here. One is roll up and second one is drill down. Roll up operation on this address attribute is performed here. When roll up operation is applied, the size of the data cube reduces. That is, cities are going to countries. So higher level movement is present. On the other hand, drill down is performed on the quarter cube time cube. Then the Q1 is changed to the months January, February, March. Drill down operation increases the size of this dimension, multidimensional, or increases dimension. A multidimensional data cube commonly used for data housing, showing the summarized data. Here, the summarized data are resulting from drill down and roll up operations on the cube are represented. So, different operations can be performed on data cube, multidimensional data. They are known as online analytical processing operations or OLAP operations. By providing multidimensional data views and pre-computation of summarized data, the data warehouse systems are suited for online analytical processing. This presentation allows the data at different levels of abstraction. This allows we can view the data at different level of abstraction. So this is a brief introduction to data warehouse. The next data repository is transactional databases.